Recording started. Um, Welcome, Devago, to this discussion of the YouTube videos sent by Arun sir.
Thank you,
Um,
Anik. So
my first,
yes,
let's
yes,
start. I will going to question you at first. What do you understand by adaptive control? Can you
yes.
please tell about that?
There are some situations where we have some controller which is being subjected to let's say small disturbances. So and then there can be situations where the controller can be subjected to large disturbances. So let's say there is a controller which is made up for small disturbances. Suddenly the system has faces large disturbances. So how it is not supposed to withstand such disturbances. Similarly, vice versa. So, like large disturbance systems may not even differentiate between signal and small disturbances. So, for that kind of system, we need a flexible controller. I mean, that kind of controller which can differentiate according to the kind of noise it's getting. That by that I mean it can adapt the as per the type of disturbances it's getting. So this type of in these scenarios we the controller we prefer are called adaptive controller.
I mean, the next question is, what do you understand by estimation of dynamic system?
So the estimation of dynamic system, there are basically two types as taught by sir in video. So first type is online estimation and second type is offline estimation. So in offline estimation, there is basically no relation between the data we are taking and the time at which we are taking the data. So the uncorrelated, there is no relation. So,
Yes.
but in case of online system, when the system is working, we take data at that time. So that means that the time at which we are taking the data does matter when we do the estimation of the system.
Yeah, thank you. Now you ask some questions to me.
Yes, Anik, can you tell me about least square estimation?
Yes, this least square estimation method is one type of regression analysis method. This we use for to predict some values according to our need, because in this basically in this system we just construct a line from in a xy plane. Suppose we take a xy plane, I mean x and y. Then we construct a line by construct a line from mainly it will be on the positive quadrant where x and y will be positive, because in the physical system all the dots or all the possibilities are in the positive ones. So in this method, in this machine learning method, or in the statistical methods, we just determine what type of values we actually need to predict the model, and we basically distinguish what type of value we need to predict the next value and what type of value we have to discard in this system. By this system, we just draw a straight line which comes from an intercept from in y-axis to the infinite, tends to infinite. uh, Suppose we take that the lower portion of values we will consider, then the machine, if we train this algorithm to the system, then the machine will always be focused on the dotted dots or the points lying lower the straight line, not the upper line. This is the main fact of this regression analysis. We can determine it by I mean, we can represent it by I mean, what can I say? It's a straight line like y is equal to ax
Yes,
plus
yes,
b,
yes. Okay,
where y is output and x is input. You can
okay,
next
Anik.
questions.
So, can you tell me about single value decomposition?
This is one type of single value decomposition. Is one type of, you can say, matrix multiplication. It's basically improves the system, or it's one type of things we have to need in the adaptive control to make a system system matrix positive definite. In this the operations of this single value decomposition is that u into sigma into v transpose. Here u and v is the orthogonal or you may say orthonormal. Sometimes it's orthonormal vector basis also. It's a kind of orthonormal, or I mean, for specified it's orthogonal. It's orthogonal vector matrix by which these matrices are used for to rotate, and the middle one is used to the positions by from which we are starting. I mean, for the sigma matrix is basically denotes the system matrix, or the, I mean, what is a, if we are experiment on the system, that system represent that system eigenvalues, and the corresponding eigenvectors we will determine will be represented by that sigma matrix. By choosing the appropriate u and v, we have to make the system positive definite. For that we have to, for which will drive our system to work in a stable mode.
Okay, Anik, I got it. So my third question to you will be: can you describe recursive least square method?
I mean, it's a recursive least square method, and or least square method is kind of one type of same, but there is one, in the linear regression theory. The linear regression theory mainly depends upon the present value, and this present value will always be depending on the past values. Means that every recent value will be depending upon its past value. So I mean, there is always a, I mean, dependency of the past value. So this recursive algorithm just, if we start from point A, go to point B, then it will always consider the point A, then it will go to the point B, then point C, then point D. I mean, it's kind of, it will call back its own, by which our system will never ever miss any point. If we physically experiment this, then we can bring that as a, if we consider input and it is the output, then in between we have a system block, and we have to back channel it with this, we have to feedback it with a model, and that will be an KT, and it's a gain. The gain here is used for the, I mean, you can say for fastening the system response or something. In this, the recursive algorithm basically, you can say it's basically depends on the weighted average. I mean, weighted average by which we can, I mean, you can say if we consider the first, if we consider the present state at theta t, then it will be as theta t is equal to theta t minus 1 plus kt into y of t minus y of t theta. I mean, this is the main thing, and from here we can determine the kt. By determining the kt, we can go ahead with our calculations. That's all from my side. I mean,
Okay, so do you want to ask some questions?
yes. Now can you tell me how do you differentiate the recursive least square and the Kalman
Kalman.
filter? And can you tell me what is Kalman filter? I mean, you can
Yes, yes,
specify.
yes. So now, right now, you discussed about recursive least square method. The thing is, ki both Kalman filter and recursive least square method have lots of similarities. Given as the block diagram for both are same, but there are some specific differences which makes Kalman filter, I would say, slightly better, because Kalman filter, I mean, considers the system noise. Okay, so as if the system can't be ideal, so there has to be some noise. So Kalman filters are considers two kinds of noise. One is process noise, and another one is measurement noise. So also, as in recursive least square method, Kalman filter also depends on previous parameters. Okay, and the gain, there is a gain which is present in recursive least square as well as Kalman filter, but the gain we denote it by KT. But the difference is the gain in case of Kalman filter will also consider noise, so it will be, the gain will be different from what is in case of recursive least square method. Okay,
Yes.
so basically this is the only. I mean,
So thank you. When can you, will you ask me anything?
yes, yes. So I will go with. So can you tell me something about function approximation theorem?
Yeah, this function approximation theory is basically a nonlinear identification theory. This is basically a linear function series of basis functions, and this basis function can be categorized as a three. That is, one is a radial basis and a wavelet, and another one is neural network.
So here you said neural network. So can you give me some brief idea? What do you understand by neural network?
Means this neural network this neural network concept is basically very popular in the recent times because this is the one type of hot topic in the machine learning. This neural network is comes from our human brain because our human brain consists of approximately 86 billions of neurons. So for that neurons, then every neuron is channelized to means interconnected to each other. In the same way, in this neural network system, or the artificial neural network system, because we are just going from one node to some subnode, then some subnode, then to some subnode, and going through the lower level. And if we to optimize the functions, we use the algorithm to go from bottom layer to top layer, because every node have one weighted value. By seeing the weighted value, we have to cancel we are canceling the we are canceling the weight, canceling the node, and we are going upwards to find the optimized path by which we can train our model to get our predicted, or at our and the values which we desire at the end. This is basically the fundamentals of neural network. This is artificial neural network. In the recent space, there is some convolutional neural network in this, which can be used in the deep learning. That is out of scope of this video. So, and this all for my side. At
So
the last of the meeting, I want to ask one more question to you. What do you understand by exact linearization?
right now I asked you something about nonlinear system. So it's also a kind of nonlinear system, but in this case, it's also called lifting linearization. Okay, so it's called lifting linearization because we what we do is we take the nonlinear system and recast it into higher dimension. Okay, so at higher dimension, the system behaves as the system should behave when it would have been a linear system. Okay, so this type of linearization comes with some kind of condition with it. So first condition is key, uh, like this type of this linearization is applicable only in systems, autonomous systems, which does not have any kind of input. Okay, so the second is key, as I mentioned, key it will be lifted in some lifted in space where it will be a it will be like a linear system. So the dimension of the system in which we are going to lift the nonlinear system must be of infinite. Just it will be of infinite dimension. Okay,
Okay.
so that's pretty much about
That's
exact linearization.
okay. Thank you. Thank you
Thank
for
you, Amit.
attending this. Now we are going to end this meeting. Thank you.
Thank you, Amit.